Hi, everyone. Before we start today, I just want to remind everyone that I'm starting my office hours starting today between 1:30 and 2 o'clock for statistics students. And it's completely optional. If you ever want to talk to me in person and ask questions, you're welcome to join me on Google. It'll be in Gmail in the Hangout section, and I'll be there and probably send a link out to everyone so that if you want to join, you can click on the link. If you don't need to talk to me, you can just ignore it. But I'll be there every day from 1:30 to 2. Okay, so with that, I want to start where we left off. And this is the homework that you had on Friday. And the blue writing are the answers. So basically, if we have a claim, the complement, the null hypothesis always gets the equal sign, whether it's a claim or the complement. And the alternate hypothesis gets whatever is not in the null hypothesis. Okay, today we're going to move on to what do we do with this null hypothesis. The entire process of hypothesis testing is what do we do with the null hypothesis? And based on what we decide on null hypothesis, we'll decide whether we believe the claim or not. Okay, so the null hypothesis is our focus right now, regardless of what the claim is. It could be the claim or the complement, but we'll just focus on the null hypothesis from here on. Okay, so the next step is we're going to use the same example. My claim was that 40% of students wake up before 8 a.m. Okay, here's the list in symbolic form. Claim is P is equal to 40%, 0.4. Complement is that P is not equal to 0.4. Null hypothesis is P is equal to. Alternate hypothesis, H1, gets P is not equal to 40. Okay, so now the next step is to see whether 40% is believable or not, is to take a sample. So we'll take a sample. Once I take a sample, we decide to believe the 40% at 95% confidence level if the proportion from the sample is in the middle 95%, just like we did with the confidence interval. We'll believe if the sample proportion is within a certain distance away from the center in the normal distribution. So if we say confidence interval is 95%, that means my z-score, the critical value, on the right side is z sub 0.025, 1.96, that's the z-score. And on the left side, now we have to consider the left side as well, which is negative of the z-score on the right side because it's symmetric. So this z-score on the left side is 1.96. So if we take a sample and I have a proportion p hat, and that has p hat has a z-score between negative 1.96 and 1.96, we'll say we believe that p is equal to 0.4.